Now I'll discuss Wittig reaction. So this is a Wittig reaction where aldehyde and ketones are converted to substituted alkene by using phosphorus ylide. You can use phosphorus ylide for this conversion. Now the same reaction is given here in a general form. You can take aldehyde or ketone. This R means what? Either H you can join here or you can take R. So you can take aldehyde or you can take ketone. And these species which is shown on the arrow is called phosphorus ylide or phosphonium ylide, because you can see here phosphonium ion. So what is the meaning of ylide? The species having positive and negative charge on the adjacent atoms is called ylide. So any species having positive and negative charge on adjacent atoms is called ylide. So because of phosphorus, it is called phosphorus ylide. There is a bond between phosphorus and carbon. You can see here carbanion and the phosphorus bearing a positive charge. You can draw even it's another resonating structure. So for this phosphorus ylide, you can draw another resonating structure, and that structure is like this. So either you can show that phosphorus ylide by using this formula, or you can show by using this formula, one and same. But we need here these two ions for the mechanism. That's why I have selected this form and not this one. So this phosphorus ylide. Now see what happens in general. So you have to just break this part of the phosphorus ylide and replace with oxygen. So oxygen of the aldehyde or ketone will go to the phosphorus, at the place of phosphorus, at the place of not phosphorus, at the place of carbon, and this carbon along with its substituent will directly go to the place of oxygen. So double bond will remain as it is. So you can see here this bond is now moved from this phosphorus ylide to the oxygen of this aldehyde or ketone to get alkene. In fact, this is substituted alkene. So we get here substituted alkene, and you can see here this part of the phosphorus ylide, means carbon of phosphorus ylide, is now replaced with oxygen. So this is called triphenyl phosphonium oxide. Triphenyl. So pH means benzene ring. So this is a pH. So this is a pH. So triphenyl phosphine oxide is produced in this reaction. So you see here. Now, I have taken here one example, this ketone, cyclohexanone. As I mentioned earlier, I have to remove oxygen. And I have to replace this oxygen with whatever portion is there in this phosphorus ylide by keeping that double bond as it is. So you keep that double bond as it is, and being this CH-CS3, so you can write without showing that bond, just like CH-CS3, that is one and same, or you can show both bonds H. So I just replace oxygen with this portion, or I just exchange that part of the phosphorus ylide with the ketone. So oxygen is taking this position and this part is going here. So this exchange is actually taking place to get here alkene and triphenyl phosphine oxide. Now how it is happening? The path of the reaction is nothing but the mechanism of this reaction. Now see here, this carbonyl compound you have to target. So the carbonyl carbon is always bearing positive charge and oxygen is always bearing negative charge. So you bring opposite charges close to this, parallel to this. So carbon bearing negative charge. So you bring this carbon below the carbon, and below oxygen your phosphorus will come where positive charge is present. Now see what happened. By using this lone pair of the carbon, there is a formation of bond between this carbon and this carbon-carbon bond. And this pi bond is moving in between oxygen and phosphorus to get this four-membered ring. So this is called oxophosphate. This is called oxaphosphatane. This is oxaphosphatane, where a very strong phosphorus oxygen bond is produced. Now the next step, so actually this is step 1 and this is step 2. In next step, there is elimination of triphenyl phosphine oxide. So you have to eliminate that triphenyl phosphine oxide. You can show the bond movement by using these curved arrows. This bond is moving in between phosphorus and oxygen. As I mentioned, this bond is very strong. And the bond, the carbon phosphorus bond, is now moving in between carbon and carbon to get alkene. So the alkene is produced and we get here triphenyl phosphine oxide. So in this way, Wittig reaction takes place. Thank you.